going to be doing several triangle congruence problems, and not only will I show you what rule makes the triangles congruent, but also the thought process behind each of these problems. In the first example, I'm told that segment AB is congruent to segment BC. So first of all, I should mark both of these congruent to each other. So I have that taken care of. BD bisects angle ABC. So if the angles bisected, that creates two congruent angles. I'm going to mark those two angles here. And finally, you'll notice I'm not told any other congruent parts. I'm not told any other given information. However, you'll notice here there's a shared segment. BD is shared by both of those triangles. If you're doing a two-column proof, you would say that those two shared segments there, BD for the left-hand triangle and BD for the right-hand triangle, are congruent by the reflexive property. And now you can take a look. Remember, you only look at one triangle and its markings. And so you can see here, for example, if I take the left-hand side triangle, I have a side here. I'm going to move around the perimeter of my triangle. Notice as I move around the perimeter of my triangle, the next angle isn't marked and the next side is not marked. So I'm not able to create a chain going that direction, but I'll be able to go the other direction. So I have a side, I have the angle next to that, and then I have that shared side on the other side. So that is a side, angle, side congruence between the two triangles. Let's take a look at example number 2. In example number 2, I am told, first of all, that angle XYZ is bisected. So if that angle is bisected, it is divided into two congruent angles, and I'll mark those two congruent angles. I'm told that XY is congruent to YZ, so I'll mark that. And once again, you'll see that I have a shared side between the two triangles. So I could mark this shared side here. If I mark this shared side, the triangles would be congruent again by side, angle, side. This problem has additional given information, however. So another possibility that I could use to prove these triangles congruent would be the perpendicular lines. YX and WX are perpendicular, forming a right angle. YZ and WZ are perpendicular, giving me another right angle. And so in addition to having a side, angle, side relationship, had I decided to use that route, under the current labeling, I have an angle. Now notice once again, I can't go to the left-hand side because I don't have the next side or the next angle marked, but I can follow clockwise. I have an angle, I have a side, and I have another angle marked. So these triangles are congruent by angle, side, angle. Again, in this example, you could have also done a side, angle, side had you chosen to use the reflexive property. So some proofs you're going to have multiple ways that you can come to your conclusion. Okay, in this problem, just given triangles with markings already in place, main thing here, this is an angle, angle, angle relationship. If you remember from class, an angle, angle, angle relationship doesn't guarantee that you have congruent triangles. Those side lengths could be different lengths and the angles match up. One triangle could be a dilation of the other triangle, even if only a slight dilation. So those two triangles are not necessarily congruent. So the relationship there is angle, angle, angle. However, that's not enough information to prove congruence. Okay, they may or may not be congruent. Can't say that they're not congruent, we just don't know that they are. This situation here, you can see I only have one angle, one side marked for each of the two triangles. However, remember that vertical angles are congruent. And so I can mark my vertical angles here, and now notice if I follow around the perimeter of one triangle, I have an angle, followed by a side, followed by another angle, and an angle, side, angle congruence. Moving on to the last example on this page, you'll see I've already marked two angles congruent. I have angle 1 and angle 2 congruent. I also have two sides marked congruent. I'm also told that this long side is congruent to the long other side Those two things are congruent to each other. And you'll notice that I'm told that M and N are midpoints. Remember, when you have double midpoints, double angle bisectors, double trisectors, double statements in general, you may be working with one of the properties. And if you remember, one of our properties states that halves of congruent segments are congruent. Well, I have midpoints for both of these congruent segments by the division property. Segment EM is congruent to segment NG. And finally, you can see my triangles here are congruent by side, angle, side. Now I'm going to move on to another set of examples. And you can see here, I have an example problem with the circle. First of all, I'm told that angle TOS is bisected, which of course is going to give me two congruent angles. In addition, notice that this is in a circle. We know that in a circle, all radii are congruent. So TO is going to be congruent to OS. And remember the reflexive property. I have a shared side between these two triangles. So we can say that OP is congruent to OP. Once again, you want to make sure that you're moving around the perimeter of only one triangle. In this case, I have a side followed by an angle followed by a side. If you need to draw that separately, you can kind of do that off to the side here. That's the relationship I have for one triangle. So a side, an angle, and a side. And that's going to be my congruence rule. Moving along here. Notice, I have a side here. I don't have the next angle or the next side. So I cannot continue my chain going in that direction. If I'm going to continue my chain of congruence, I always have to have the next side or the next angle marked. However, you see that I have a side marked here. I don't have the next angle, but I do have the next side marked. And then I have the next angle marked. And you'll notice here, this is one of our classic, well, class we call it the ASS triangle relationship, but this is ordered the opposite direction. This is the SSA relationship. Remember that SSA is not a method of proving triangles congruent. It's possible to create more than one pair of triangles, or more than one triangle, using that information if you're given two sides and an angle measure in that order. And as a result, we say that there's not enough information to prove these two triangles congruent. Okay, now, moving to overlapping triangles. You can see that AB is congruent to BC. You can see that angle A is congruent to angle C. And AB is this longer segment right here. And of course BC is this longer segment over here. Notice I'm trying to prove the overlapping triangles congruent. That's BAN. That's this whole triangle all the way along here. Congruent to BCM, which of course is the other overlapping triangle. Personally, I have a lot of trouble seeing the congruence in these problems. I would highly encourage you, if you're going to show overlapping triangles congruent, to draw one of your two overlapping triangles separately so you make sure you get the correct rule based on your markings. So I'm going to redraw triangle ABN, and I'm going to put the labelings again. I'm going to add the labelings again. So angle A got marked, side AB got marked, and you'll notice the two triangles don't have any other given information. However, notice that both triangles share angle B. And according to the reflexive B, that is the same, according to the reflexive property, that's the same angle B for both of those two triangles. So as a result, I can mark that angle B and check out what I've got in the picture now. I think it's very tough to tell in this diagram what's going on. But if you look at my simplified diagram, when I'm looking at just the markings on one triangle, it's an angle followed by a side followed by an angle. That is angle, side, angle, congruence there for those triangles. Moving along to the final example, I'm told that AD is congruent to BC. I'm told that ADC is a right angle, that BCD is a right angle. And notice I'm trying to prove triangle ADC congruent to BCD. That's the overlapping right triangles at the base in the picture. In fact, I'm going to draw ADC again. Notice for ADC, again, I do my separate drawing here. I have this segment marked. I have the right angle. Right now, even though it kind of looks like there's something marked over here, that's the whole angle for the triangle BCD. So I need more markings here for these triangles to be proved congruent. And notice what I have. I have a shared side, shared by those two overlapping triangles, side CD. That is going to be the same for both. And when I add that to my picture, now you can see it's a side, it's an angle, and a side congruence. That is an SAS congruence. And at that point, I am done.